Okay, in that case, let's start with it. Before anything, welcome everyone and thank you to be part of this. And I'm hoping that you won't fall asleep during this presentation. And I think it's going to have a good time along with all of this. So, without further introduction, my name is Ricardo Neves. I've been an ActionScript developer for too long to care to remember, honestly. ActionScript 2, even before that, forget it, it's dead. Besides that, Java and Scala enthusiast, testing addict, unit testing, one of that guys. And for every cat owner, I'm also a cat test subject or underling power overlords. And I've been working for InnoGames for almost 6 years now. So what are we going to talk about today? So I'm going to start with life as an ex-developer in Forge, which is a really small presentation about what we do. Then we're going to move to the main topic, which is improving our code base using Haxe capabilities. And finally, I will hand over to Nick, which will talk about the coding guidelines. So moving on, life as an ex-developer in Forge. I choose this cartoon to put it here because first, it's a cool one. Sleeping makes me angry and eating makes me sleeping. Therefore, life is good. It's always good to listen to the great cat advices, in this case, Garfield. And what I mean with this cartoon is that developer life, it's kind of cyclic. We usually do the same stuff or more or less the same stuff. While we do have fun coding, sometimes we need a bit of extra fun. And this revolution in Haxe actually allowed us to have a bit more fun that we usually had, even in the past as an ActionScript developer. So let's talk briefly about who we are. So we are the front-end team, and we are a team of front-end developers that are scattered across 3 different teams. And each team have their own responsibilities and specialization. So besides that, every team that we have is self-sufficient. It contains alt components and so on, like front-end, mobile, back-end, game design, QA, you name it. We have it all in each team. But this doesn't mean that we only work on that on each team. Yes, we tend to work on that, but we also support each other. We also change teams sometimes. We also have our Inno days, which happen every sprint, where we have 1 day to develop wherever we want, as long as it has any value to the company. But most of it, we share responsibility and support each other. So, in a nutshell, what do we actually do? We do things like this, like events. As you can see, we do content like units, we do content like buildings, we do technical stuff, we do a lot of things. And exactly how we do it, we usually plan, discuss, and create new game features in a really friendly and relaxed yet professional environment where everybody contributes with ideas, we discuss, we brainstorm, we gather a consensus, we implement, and hopefully also bug fixing, it makes part of it as with any development. But on top of all of it, at least for front end, we do have fun. And we strive to improve our code base using the latest Haxe capabilities and everything that Haxe has to offer. And on that note, let's move it to the main topic, improving our code base using Haxe capabilities. Before we starting, we should look at where we were in the past. So when we finished the conversion, and I'm not going to talk about conversion, we already gave a lot of presentations about this, so enough. Let's just say that by this time that you can see here, the Great Migration branch was created, and we finally move away from ActionScript. At this point, there was no more ActionScript developer. We moved completely to Haxe. Everything was done in Haxe. And in that exact point, what we had. So we had a lot of ActionScript conversion artifacts. We had untyped arrays, vectors, conversion helpers as dictionary objects, any. And we also need to support at this point both HTML5 and Flash. And we were creating to Flash from TX. But there is one thing that you need to keep in mind. At this point, our code base, even it was Haxe, it was mainly ActionScript described in Haxe. It's not something that you would get if you would code it from scratch in Haxe. It was something that while it's written in Haxe, you look at it and you recognize ActionScript. And therefore, we had a lot of legacy code tied to outdated coding guidelines that were created for ActionScript that no longer made sense now that we are using Haxe. So, what we wanted? First, we wanted to have an updating guidelines which will reflect Haxe and not ActionScript as we had. We also wanted a strongly typed code. And I'm not going to even dig into it. We are believers in strongly typed code, and we don't like dynamics, and we really enforce this thing. But what we really wanted also was to have a more maintainable code, or readable, simplified, escalable, generic, you name it. We also wanted less bullshit, or as we say, technically, less boilerplate code. On top of all of this, we wanted more freedom to explore and do things, or we wanted our code base to evolve from what it was in the past into a really Haxe code base and not an ActionScript one. So the question is, how do we do it? How do we introduce new stuff into our code base? Again, we just start by having some fun and exploring and trying things. And then we just use some set of rules that we decided within the component. We do this exploration. We take it to the discussion among our peers, the entire front-end component team, and then we refine these ideas, and then we make a decision about should we add this to the code base, should we scrap it, or whatever. One thing that I left out of my self-introduction is that I'm also a professional when it comes to annoying Dan. And Dan has been a really driving force behind all this evolution. And I really don't know how he still has the patience to reply to me and answer all my stupid questions that I do sometimes. So on a personal note, thank you, Dan, for your patience and your help driving all this evolution forward. So back to it. So we started to do some small improvements, like keep in mind we were green in Haxe by this point. So we were starting to explore things and starting to do some stuff. And one of the first ones was type defs or anonymous structures. And what we use this thing for? You use it to create configuration payloads, abuse it with struct init, and we started to getting some really fancy and crazy systems. I'm going to give you some small examples of it. This, for instance, is a configuration for our event system, where in the past we have a bunch of commands to create something that now can be described in a single class with code completion and without tons of bullshit that we had in the past scattered across the globe. So this is one example of things that we use to type devs. Or we will pair them with enums and start to doing some crazy systems like this one that I'm going to show you here, which is a confirmation window that has the configuration based on anonymous structures and enums, where we use this thing a lot of times, although I don't remember at all how this thing is used. But the good thing is that I don't need to know, because the VS Code completion will tell me exactly what I can have in each of the required anonymous structure that we have there. And this is one thing that it speeds a lot of creation for even for this thing. We had tons of copy-paste confirmation windows that then had to remove when implemented this, which we no longer have by having a simple system like this. So moving on the improvements, the second victim was enums. Now, one thing that you need to keep in mind is that we have tons of constants in our code, like really tons of constants, as you can see on this screenshot. And because we are type safety addicts, we wanted to have used proper enums to describe this thing. I mean, take a look at both functions that you have here. They look exactly the same, but they are not. Because if you look at the right side, the type here is an icon type, where on the left side is a string, which means if I pass to the left side get icon bullshit, the compiler will tell me that's fine. But if I try to do the same on the right side, I will get a compilation error. Again, type safety to help us. And not only in these cases, but we also using enums to replace some complex strategies, as you can see here, where we can have like text, images, resources, you name it. And if you will go to implement this in a base class approach, it will be a nightmare. But we could also use them as to define sets of values, as we have here in the right, or even going a bit more crazy and having abstract with type parameters, and again, enforcing us to have type safety in a really cool way. So after enums, we're starting to dig in a bit more, and we come into the abstract, not only the abstract classes, but the abstracts themselves. And this will also allow us to start implementing real abstract classes and tons of other stuff that was a bit problematic in the past. We also started using static extensions to expand our own API on things like arrayutils that provides methods to help us with the arrays, or future tools, which is a static extension that allows us to add more functionality on top of the features that something provides that we're going to talk next. So besides that, we started also using function bindings. I was really surprising with this one and really loved it, especially with the animations, like passing parameters all back and forth instead of that just start binding in them, or even for some other stuff. Also, the inline functions, we started using them to improve readability. Yes, it won't generate extra function calls, theoretically, because you're going to have them into JavaScript side anyway. And they have also some downsides, but yeah, we also exploring that. Besides that, we start using generics, where we have a base implementation depending on the type that just have to using these multi-types and others that allow us to create real base classes without duplicating logic and a lot of other stuff.
Boom, let's go, baby.
And finally, we come to macros, which I usually call Haxe Black Magic, or when you finally think you understand something, you don't. I think majority of Haxe devs will, besides Simon, of course, will concur with me on this one. So we use macros to generate code that will serialize or deserialize our VOs from backend. And this is not done on runtime, it's done on compilation time that will generate automatically this code on these VOs, all of them. We also use them for static extension helper methods. We use them as build macros and many other cases like creating commands with events mapped and another thing. Like some examples here is the one that actually generates the code to serialize and deserialize the VOs. Another example on the future tools that we're going to talk later, where we are combining features. And this thing is really cool. I'm going to show an example on it later. Or even builder macros that are actually creating the versions that we use in-game and export. So at this point, there was a lot of changes in the Codebase, and really a lot of them. And it started to look a bit more like an Haxe Codebase than an ActionScript Codebase. But we decided, you know what? We need to think differently. Not think differently to Mac way, but think differently with ThinkCore. So to start to getting different results, we needed to think differently. And we introduced the ThinkCore into our code base, which allow us to get a really nice things like callback links, futures, promises, signals, and others. And with this thing, we started to get bolder and do things completely different. So I'm going to give you an example. When we were to call backend, we will have something like this. It was actually way uglier than this, but this is a simplified version. We will need to have a callback to the method and service. We will need to show some loader icon. We will finally get to call the backend method. And then we will get some response. We will need to hide loader. We will need to downcast the response from backend and finally do something with it, which was really, really, really messy. And with ThinkCore, what we have now, we have something simple as this. We started using futures, and with it, we simplified a lot and introduced a type safety to the backend calls and everything. And it's really way better than we had. And let's try to dig a bit into this example. So what we have now is that the servlet itself, instead of a void that we had in the past, now returns a future on the concrete type that we're going to use. By using static extensions again, the icon loader thing, it's handled by simply requesting with generic loader here. And we don't even care to destroy it later or something like that. It will be done automatically on response. And finally, we can handle the response directly, and this response will be strictly typed. So no more casts or any bullshit like that, which is really, really awesome. So with futures, we started to think and use the handling the asynchronous calls in a way much different that we had in past. And the futures from ThinkCore does not only allow this, they also allow to be run in parallel sequence, and with our future tools, they can be combined, and then they can do really cool things. So I'm going to move into a simple scenario here that we actually deal with a lot of times. It's simply getting to call backend on some methods and load some assets, and once both are ready, do something with them. So this is our example scenario. And this is how we will do it in the past. We will basically have a command where we will simultaneously try to get the overview and loading the assets. And when one of these things will get a response, we will finally check the load state, which means if both of them are filled, then do something with the data. Either this or first load one and in the response load the second one, which is not better than this. And keep in mind that this is already simplified because we are already here using futures. So what we actually have now on this same scenario, we have something simple as this. We just combine both futures and call the backend and the asset loading. And when they are done, we just do something with them, which is way different and way better than what we had in the past. Going a bit more crazier, let me show you another example. Here we are loading, calling multiple services. We are loading multiple asset libraries. We are also recovering errors here. And doing this in the past will require like a lot of flags and will be really crazy. And now we can just do it simply as with something like this. And we do not only use futures for this, we also use them, for instance, in animations, because luckily or not, you might decide it, we have really crazy game developers, which comes with really weird ideas on animations and flows. I want this to do this and then do that and then do something else. And we devs need to implement their craziness. And this is one example where with futures and in sequence, we are actually doing multiple actions and animations with futures. So as you can see, the futures themselves changed a lot in our code when it comes to asynchronous calls. But not only futures, we're also using promises, usually only when we had to handle fail, which we usually don't. Signals as well that we had in the past. And because TeamCore also provides it, we just replace the library. And finally, callback links that we use a lot on internal stuff, as well as we're going to see next. So, as I said, there was a lot of changes that were introduced with TeamCore. And with it started the code started to look a real Haxe code base. And therefore, that's why we call it a revolution. Because at this point, it's a really different code base. And if you will call some developer that checked the same code base 1 year or two ago, he won't recognize it in a lot of things. One other improvement that we have made, simple one of many, was our asset systems. So we have our assets organized in Texture Atlas, and the way that we had them and still use it, we are still migrating this, was basically to get the images that we want from this Texture Atlas by using the name of the image that we want. And when you have a huge asset library as we have, I don't even recall the size now, it's really huge. It's really tricky and painful to figure out what assets do you want and how to deal with when they are removed and things like that. And so we started to using something slightly different, which is the type of ref libs. So now, when we generate this texture atlas on our asset toolchain, we are also generating some classes that contains the assets that we use. And with this, we not only get the preview on VS Code of each asset that we have, as this will be again strictly typed. And this means that if any artist remove an asset or something, our continuous integration system will fail. And therefore, we are enforcing some type safety on the assets that we have, which is a really, really good thing. And therefore, we are addressing some of the issues that we had in the past and no longer have. So is still everyone here, or did we lost half of the screen already? Just wondering. Okay, let's go to another type of improvements. This time UI related, and again, think different. And what we decided this time was to, after ThinkCore, to reintroduce ThinkState. And with ThinkState, we started to have a reactive state handling. And therefore, we started to using this modified third Newton law, which is a bit different, but allow me. So for every data state change, there's going to be a reaction only and if only the observed data changes. And this is something really cool because it will allow us to do something like this. Pick this example. This is one of our main application models that we have. And in this model, we have this timestamp. This timestamp, it's the timestamp of the client. And by having here an observable, we can use it in something like this. We just bind into any function, and when this timer changes, we can apply text fields, we can trigger calculations, we can do tons of things without creating new timers, without registering callbacks to some timer handling or something like that. It's way more clean and way more, it's really better, at least in my perspective. Now let's go a bit more crazy with observables. And what you see here, it's actually real code that we have from our pagination system when we have multiple pages in any of the rankings or whatever page that you want. You usually have left, go back button, go to the right. We have the text field that allows you to move to a specific page. And we had a nasty controller handling all of this. Like every time that the user clicks this button, check the state, check whatever, and it was really painful. What we have now, it's a view model, simple view model, where you have a state of the current page, but you also have derived states on this observable autos that will immediately trigger to things like for the as previous and as next, which will automatically, when binded, enable or disable to go left or go right buttons and other really things. So basically, it allows us to react to data change without having events dispatched from model and reacting to some part here, then reacting to some part there. No, we just react directly to the data that has changed. And states and observables allow us to do this thing in a really clean and efficient way that we really like it. So moving away from think, one other thing that we introduced was, which we are actually now, we found a better replacement for this one, which is the disposer. So the disposer was basically a mean that we had to ensure that everything that we create in a view is destroyed. And instead of doing it like this, like we had in the past, now we use something called on stage handler, which basically, when something gets added to stage, it will react. And when the view is, when the view is added or removed from stage, this stage handler will react according to it. So let me give you an example because developers usually go better with examples. So on this specific stage handler, which means when this view is added to stage, something's going to happen. So we're going for the example, we're going to bind again one of that application times and use it to set some text on some text field, set some progress bar, and again the fun part of this is because it's registered as on the on-stage handler, this means that this callback link that is going to be returned from this function will be destroyed when this view gets removed from stage automatically without caring about anything more than this. And again, this is just some examples that we have on improvements that we have made. We have way more than this, but again, we don't have much time to bore you with these things. So let's talk about future plans. What are our future plans with this? So the first one is the complete removal of the AS3 conversion artifacts. And we already have done a lot, removed a lot of them, but there's still some of them that we need to purge them somehow and get rid of them. After that, we also want to improve and continue to improve the type safety of our code by using more enums, abstracts, and others. I mean, I said it many times, we have tons of constants, and we should be using enums, not constants there. And we are striving to improve that. And one other thing that we want to do, and this was actually triggered by one of the Haxe apps, which is shared logic between components. As I said in the beginning, we have basic backend, front-end, mobile, and sometimes we have some complex logics that we want to have shared across the three components. So ideally, we want to write this in Haxe and have it also in PHP and C++ with only the Haxe code and maintain it like that. It's something that we tried, it didn't work, but we're going to go back to it and we'll see this working. Besides this, we are also searching for UI solutions, some builder tool, some framework or others. We are deeply exploring with this, and we're going to get some ideas and solutions for this. But on top of everything, what we really want is also to keep exploring and improving our code on daily basis and just moving on and having fun, and whatever Haxe get to us, we want to use it and abuse it. And on this note, I would like to ask the Haxe Foundation for coroutines. Please, Simon, think about it. We want it really badly. So hack your brain and give it to us, please. So thank you for your time. I'm going to hand over to Nick. And again, thank you all.
Yeah, and while we switch our screen sharing, don't forget to post your questions into our Twitch channel so you don't forget them. And we'll continue with the coding guidelines segment. But first, let me introduce myself. I'm Nick, and I've been at InnoGames now for more than 10 years. I actually started in January 2011. And in that 10 years, I worked most of the 10 years. So I have already 10 years on my belly in the project Forge of Empires. So I've been on the project since production started in 2011. And no, it didn't take us 10 years to build the game. Actually, we released 1 year later. But we've been improving the game for the rest of the time. And it's a completely different game than the game we launched at that time. During that time, the last 10 years, I became many things. As you can see here, I'm a father of 2. I'm also a scuba diving instructor and an avid cyclist. But the most relevant thing here is after being a Flash and ActionScript developer for 15 years. I'm converted and I'm now a Haxe developer. So I'm working on Haxe 5 days a week, writing code. Amazing transformation. And I think what I want to do with you now is do a trigger test. So you can contribute a bit. I want to find out from you which of the following segments triggers you. You can use a Twitch channel, write in, is it A or B? Curly brace in the same line or in a new line? Yeah, and maybe, just maybe, you have done both and you see advantages in both. No, you don't. I mean, you have your opinion about this and you can argue for this hours long because I've done this with a lot of developers. But here's something that we probably can all agree on. Just go for A or B, but don't mix them because that is just horrible. If you think this is okay, please, we're developers. We all have some kind of obsessive compulsive disorder. So please don't do that. But yeah, as we have A and B people, we also have them here at InnoGames, we have to decide one way or the other. And that's why we have coding guidelines. It's important to not mix them, so we go for either A or B. In our case, it's A, if you want to find out. And we do that for a lot of things, because there are a lot of things that are not clear. And we wrote down everything in our coding guidelines. Why did we do that? To improve the readability of the code, because you stop wondering if the curly brace goes into the same line or the other lines. It helps us really to define what is well-written code, because variable names that consist of only one letter are only okay as an iterator or something like that, but not for class members. And this is also important for us and how we work, they promote the collective ownership of our code. What does that mean? Basically, we don't have it set up the way that only one person works on a module. We don't have no author or tags in our code base. It's all our code. We're all responsible for that. I can work on any part of the game. And to enforce that and to not say, okay, this thing from the coding style belongs to this developer, every code should mostly look the same. An interesting thing about InnoGames and about the development we had here in the last year, basically we made two versions. One version is for the companies, which really makes it easier to have company coding style guidelines to switch from one project to the other, because we have several Haxe projects. But we also have some coding guidelines for the project level. But the difference, well, at the project level, we define things that are more project specific, like relevant stuff, dependency injection, where to put the variables here, stuff like that is on project level. And yeah, once you have those coding guidelines, the thing is you have to enforce them. And enforcing them is traditionally done by doing code reviews. Developer A makes a pull request, developer B looks at it. And then it turned out that usually the first code reviews for new team members is always about coding guidelines. Well, you should do that, and this is not how we do it. And, that's kind of repetitive and boring. And if it's boring, we ask, can we not automate this, please? And the picture is relevant because that is the robot my son built to tidy up his room. He's always claiming that he just needs to build the perfect remote control and it will start working. I think I passed a gene to him about automating all the stuff. But what we came up with to replace the old Flex PMD horrible abomination that we had with our ActionScript code base, we didn't have to look far. We found Haxe check style. Really suits our need. It's a static analysis tool. What is a static analysis tool? It looks at the code, and the important thing is it's not executing the code, it's just looking at the code without compiling, executing, anything like that. But even by that, it can reveal errors that otherwise would only turn up in production. We have a live game with millions of users. We don't want errors in our live code base. But of course, that is only the first step in the quality control we have established. So we have the static analysis as the first step, then the code reviews, then we have release management, we have UI tests, we have testing dojos. There's a lot going on to ensure that we deliver a high quality game. And you might wonder, yeah, what do you check with the check style? And I prepared 3 examples. And the first one is something that I'm sure most of you have encountered. Instead of a comparison, you do an assignment in your if condition, and then you wonder why A is always B, and you spend hours trying to find it until you finally, okay, no, I forgot the second equals sign. And therefore, it's not allowed to do assignments in if statements or while statements in our code base. And we configured checkstyle to enforce this rule. So as you can see, the green box a valid code, which will pass. So you can do an assignment and then a comparison. It's quite clever, but it's not okay to assign directly in an if statement. And nice thing about checkstyle, Haxe checkstyle, is that you can configure it, that you can also allow the assignment in return values. We have a lot of setters as part of our legacy code base in ActionScript, so we could allow that. That was quite helpful. The second example I'd like to show you is unused local vars. We check for those because it's not a problem usually. It gets optimized at compile times, but it's a readability problem. So we don't want them. If you never access a local variable, just remove it. I think it's quite obvious why this is helpful. And third example is something that really triggers me. If you look at the green and the yellow box, you will find out, yeah, actually that code is exactly doing the same, but I think we do agree that the code in the green box is really nicer than the code in the yellow box. So Boolean returns, that's something I'm guilty of doing this wrong also when I write the code, but it's really helpful if you automate that, if you find them, if you don't have to be embarrassed if your coworker finds it in your pull request. How did we introduce checkstyle in our project? Yeah, checkstyle, I have the link to the page later. It has about 80 different rules that you can configure, which is quite a lot already. Most of them can be configured individually. Some of them are applied twice or even 3 times in our project. Configuration is really straightforward. On the right, you can see a configuration file. It's just a JSON file. Really straightforward. You have the checks in there. You specify the type of the checks and some parameters for that. So that wasn't really hard to set up, but creating those rules and editing them is kind of a major task. So what we first did is we configured the rules that were obviously clear what we wanted in our code base. A lot of the migration we did to Haxe was about making our converter put out code that already somehow meets our coding guidelines. There were other rules that I discovered in Checkstyle that weren't so obvious. For example, we had hexadecimal numbers with both with capital and with lowercase letters, and I wrote all those rules down, and we had a discussion in the team. Do we want that rule? How do we want that configured? And then basically set it up in our project. And here's a good advice, if you want to introduce that, I set up a wiki page for false positives, because they will happen, and they did happen, but usually misconfigurations could be addressed quickly. Then the next step in our setup was using the VS Code plugin for the Checkstyle. We all use VS Code as a general tool, and it's really great with Haxe. So basically, I put the rule file in the Git repository. I set up the shared VS Code setting to point to the correct file for Checkstyle. And basically, it did work for all developers the next day. Really amazing thing. What you get is, you can see that here, basically for everything that Checkstyle thinks is not okay, you get the blue underline thing. And if you hover over it, like you can see here, you get this box specifying what rule is violated, also with a rule name, so you can easily look this up. And you also get the problem section that is there in VS Code already filled for all your open files, all the violations. Kind of neat. But of course, having it in the editor is one thing. Basically, we want also to have this as part of our continuous integration. And Checkstyle does work out of the box with Maven and Bamboo, which unfortunately we do not use. So we set it up to work with Jenkins. We're using the Lix package manager for Haxe. I can really recommend it. And also more for legacy reasons and build scripts. So calling Checkstyle from with Lix from and was set up. That did work out pretty well. But we discovered a complete Checkstyle one, especially with the copy-paste detection on our really large code base, took more than 5 minutes, which is just something we do not want. We want fast builds. We want builds a bit faster. So basically we configured it that it's only run on changed files. It's run on the complete changed files. It's not only run on the changes, because we have the Boy Scout rule. You always have to leave the code better than you found it. So actually you have to clean up the files that you have opened. And this is working pretty well. We now have that set up in Jenkins. After each build, you get the Checkstyle warnings. It's a plugin for Jenkins, easy to set up. And you get all the violations with all the files. You can look that up here. We are almost there, but not there yet, because what we will set up next is Bitbucket integration. Bitbucket is the tool we're using for the code reviews. So basically what we want to do is pass the Checkstyle output and adding comments. So basically the nagging we're doing at the code review, usually as developers, will be replaced by Checkstyle nagging and the Bitbucket plugin. And this is currently ongoing, but that's a logical next step. And then we have this integration done. And I really want to point out, have code styles, give checkstyle a try. I have the links posted here. Checkstyle even has a feature where basically it detects your coding guidelines from the code, so you can run it over your code. That's quite neat. OpenFL picked it up recently, checkstyle, so no matter if it's a commercial or open source project, it's a good thing, and you should think about that, and you should really, if you're thinking about coding guidelines, also check out checkstyle, because already configuring it, you will get a set of coding guidelines from that. Yeah, reminder again, if you have questions, if you have comments, post them on the Twitch channel. We are reading that. The questions will be asked later. I want to plug again what Max said. We are always open for new talent. Check out our career page. We are hiring. So if you're interested in that, if you like what we're doing, you should. You can get in touch with us, Ricardo and me. We will be available later in the Q&A, and you can also reach out to us directly if you want to. Here's our address data. It will be available on Twitch later and also uploaded to the YouTube channel. So thanks for all this, and thanks for listening to us, and hope to see you soon.
All right, we're going to take a 15-minute break now, and then we're going to be in with the next talk. In the meantime, feel free to post all your questions into the chat and enjoy each other's company actively.